Welcome back to Mathematical Mindset. So right here guys, in this video we have a Maths Olympiad question right here from Germany, and the question says 3 power x plus 9 raised to the power of x is equal to 27 raised to the power of x. So the first thing guys you want to do, we have to solve for x. So guys, you want to simply express 9 and 27 in terms of 3x as the first step. So I'm going to do this right here. Express 9 raised to the power of x and 27 raised to the power of x in terms of 3x. And by doing that, 9x is equal to 9 is 3 raised to the power of 2 all x, which is equal to 3 raised to the power of x all square. So we are going to write it as this. And for 27x as it in terms of 3 is 3 raised to the power of 3 or x, and I'm just going to rewrite this as 3 raised to the power of x all into 3. Alright, so we have been able to express 9 raised to the power of x and 27 raised to the power of x in terms of 3x. So the next thing we want to do is to simply substitute the expression, which is this and this, into the original equation. And if we substitute this in place of 9x and 27 in place of this in the original equation, this is going to become 3x plus 9x is, we have it to be 3x all square is equal to, for 27 we have it to be 3x all raised to the power of 3. Now right here we say let y be equals to 3 raised to the power of x, and let's rewrite our equation. If y is equal to 3 raised to the power of x, this is going to become y plus y squared is equals to y cubed. Alright, now let's simply rearrange our equation to form a polynomial equation. So rearranging this, we are going to have y cubed minus y squared minus y is equals to 0. Alright, now all we want to do is to factor out the polynomial equation. Now factoring out this equation right here, we have y to be a common term, so y into y squared minus y minus 1 is equals to 0. So from this part, if we solve the factor equation, we have that y is equals to 0, or y squared minus y minus 1 is equals to 0. Now we already know that y is equals to 0, and we can easily solve this equation right here by making use of the quadratic formula. So we're going to say solve y squared minus y minus 1 using quadratic formula. So we're going to solve this using the quadratic formula, and the quadratic formula states y is equals to minus b plus minus the root of b squared minus 4ac all into 2a, whereby we have that from the equation we have that a is equals to 1, b is equals to negative 1 from this expression, and c right here is equals to negative 1. So by solving this out right here, we know that y is equal to, place of minus b we have negative 1, so this is going to negative into negative 1 plus minus the root of b square is minus 1 square minus 4a is 1 and c is negative 1 all into 2 or into 1, which is 4a. So we have here that y is equals to minus times minus is plus, so it's going to become 1 plus minus the root of minus 1 square is 1 minus 4 times 1 times minus 1 is going to give us plus 4 over 2, and this is going to give us y equals to 1 plus minus 1 plus 4 is 5, the root of 5 over 2. Now from this place we have that y is equals to 0. Now we cannot make use of y equals to 0 because y equals to 3x right here cannot be 0. So we simply need to discard this particular equation right here. So what we have right here, we have that y is equals to 1 plus the root of 5 over 2, or y is equals to 1 minus the root of 5 over 2. So right here, these are the potential solutions right here. But since y is equals to 3x, so you solve for x using the positive value for y. So using the positive value for y. Now we need to make use of the positive value of y. Since y is equals to 3s, this is a positive value. So we have to make use of the positive value. So we have that 3 raised to the power of x is equals to, we have for the positive value of y, we have that 1 plus the root of 5 over 2. Now we can easily solve for x by taking the log of both sides. So we simply just take the logarithm of both sides. So taking the logarithm of both sides, we have that x is equals to log 3 of 1 plus root of 5 over 2. And guys, this becomes our answer.